Alright, you guys, this is for pre-calc. We're going to combine 7.1 and 7.2 into one assignment, and then 7.3 will be its own assignment. This is about solving systems, and the ones that we're going to be looking at is solving systems of equations of lines. So when they're linear equations, and a linear equation means that your degree is 1 of the variable, of the independent variable. So we certainly could do some where you have a parabola and you're going to cross it with a line and your solutions are 2 points, or your solutions would be no points because they don't intersect. But we're going to limit ourselves to doing it when the system of equations are both lines. Okay, but just letting you know, this is totally fair game. In 7.1, the first method that you're going to be exposed to is substitution, and they're generally going to look something like this. One of the variables is going to have a coefficient of 1. So if you were to solve for that variable, so in other words, turn this one into y is equal to negative 2x plus 5, here's a y in the other equation, and this is what that is worth. So you rewrite it, 3x minus 2 times whatever y is worth is 4, and then you're going to fill into it what y is worth, minus 2x plus 5. So then you have 3x plus 4x minus 10 equals, whoops, I don't know why I wrote a 4 there. I don't know why I wrote that at all. Oh, because it equals 4. I'm a goofball. Oh my gosh, am I sleeping or what? This 4 is right there. Holy cow. Sorry about that brain cramp. 7x minus 10 is equal to 4. Man. If my penmanship is working, my brain isn't. If my brain's working, the penmanship's not. Add the 10. 7x is equal to 14. Divide by 7, x is 2. You're looking for a coordinate where the lines touch. So you're looking for an xy value. You found the x is 2. Now you have to find the y value. And you can do that by filling it back into the original equation. And you get 2 times 2 plus y is 5. That's 4. Subtract the 4 and you get 1. And it shouldn't matter which equation you fill this into. That's what I'm looking for. It shouldn't matter which equation you fill it into. If I filled it in, whoops, here, you'd have 3 times 2 minus 2y is 4. That's 6. Subtract the 6. And you get minus 2y is equal to minus 2. So y is equal to 1. You should get the same y value filling it into either equation. If you don't, then it's not the correct x value. Okay. Another way that you can be presented with the problems in 7.1 is that they're written or given to you where they're both solved for y. So it's saying y is worth this much, y is also worth this much. Well, if that's true, it's called the transitive property. So like if a is equal to b, and b is equal to c, then a is equal to c. Well, if y is equal to this, and the same y is equal to that much, these two things have to be equal to each other. So you just set them equal to each other. So, let's see. We've got minus 3x plus 2 is equal to minus x minus 5. So I'm setting these two things equal to each other. How about I add the 3x over? So you have 2 is equal to 2x minus 5. Add the 5. I feel like I'm being, like this is so old school here for you guys that it should be a non-issue, but there you go. So then x is equal to 7 halves. Okay. Now that you know your x value, fill it back into one of the equations. Either fill it into this one or fill it into this one to find your y value. And I'll leave that up to you guys because I don't think I need to take time to do that. Linear combination. This is section 7.2. The idea is if I were to just combine these equations, notice these are going to cancel out. You'll have 3y is equal to, that will be negative 7, then divide by 3, and you get y is equal to negative 7/3. So of the coordinate, you know the y value is negative 7/3. You can take this, and I know it's not going to be very pretty, and fill it back in to either equation and solve for the x value. Okay? What has to happen in order for linear combination to work is that when you add these together, one of the variables must go away. So in order for that to happen, look at the coefficients on those variables. They have to be the same number but opposite in sign. So looking at this one, none of the variables have coefficients that are the same number opposite in sign. So what you have to do is get them to become the same number opposite in sign. Okay? It's your choice which one you go after. You can go after the x's or you can go after the y's. It really doesn't matter. I'm going to go after getting rid of the y's, like the x's disappeared here, only because they're already opposite in sign. So all I have to do is make them the same number. So how about it's the least common multiple is what you're going to go after. The least common multiple between those is 12. So I'm going to multiply the entire top equation by 4 and the entire bottom equation by 3. So I get 20x plus 12y is equal to 36, and the bottom becomes 6x minus 12y equals to minus 42, I think it is, or positive 42, I mean, sorry about that. That'd be 30 and 12 is 42. So now when I do the linear combination, these cancel out. 26x is equal to 878. And I think when you divide by 26, I think you get 3. Yep, I think so. 26 times 3, 8, 1, yep, 78. Okay. So now that you know your x value of 3, take that x value and fill it back in to either equation and solve for y, and then that'll give you your y value. So I think that's all for 7.1 and 7.2. Your goal, again, for linear combination is to make the coefficients on one pair of numbers the same but opposite in sign so they cancel. Perhaps they're given to you that way. Perhaps they're not. Perhaps it's just one equation that has to be multiplied by something. Let's say this was a 2. Then I'd only have to multiply the top equation by 2 to get these to match. You don't always have to multiply both equations. Okay? I believe that's it. Let me move on over. Yep, that's it.